And Chapter 11 deals with impact program evaluation and hypothesis testing. This is a pretty concise and small chapter, but it has some really important tools for helping you to figure out how you would measure your impacts. Quite honestly, Chapter 11 is the subject of entire courses. I know that some of you have taken a research methods course, and also there's implications in here for statistics. Some of you have taken the statistics course, and even more detail in my program evaluation course. But this does a pretty good job of hitting some high spots that'll help you with your program proposal. I want to draw your attention to some of the more important parts of this chapter. In fact, it's one of my favorite chapters in this whole section. Just so that you're clear on a couple of things. I figure if you read it and then I kind of give you some examples here about my experience, maybe that'll help you understand some of these concepts. So it really is talking about looking at both impact and performance evaluation. Impact, did the rubber hit the road? Did it meet my target audience? Did it cause a behavior change? Performance evaluation, on the other hand, it would be more like, did the theory work in terms of the process? Was the actual plan carried out? And in fact, you're looking here at changes in program participants, and then secondly, you're looking at changes in the organization or community. In other words, because I implemented this particular program, did it change the way we do things around here? Did it go away from our maybe our practice or behavior as usual, our status quo? So that's the two parts it talks about in this chapter. A couple of things, they have three really good tables in this chapter. Differences between impact, program evaluation, and performance measurement. I actually just shorten that up to say impact evaluation or performance evaluation. But this chart is quite useful. They spend about a page and a half giving you some pretty good examples and discussing these things in more detail. But essentially, when you're looking at the impact program evaluation, that would be that behavior change. I want to see if I have a cause and effect relationship. That's episodic. In other words, the frequency of when you're doing the measurement, there's some sort of summative date, usually at the end of an intervention. You may even have some longitudinal dates planned out there, but that frequency is definitely an episode. You are planning to take a measurement at a certain time. The performance measurement, however, is ongoing. It's evaluating that process all the way along. In terms of issue, you're looking then at these are issues that have been formulated by specific stakeholders. They're questions at a particular point in time. You're trying to address a particular problem. So that's usually a more specific issue. But there may be complexities and factors going into the question, but you're looking at something quite specific. Performance, on the other hand, is designed to address more general performance issues that are constant over time, things that you're trying to address in a more formative way through the process. And they, as I mentioned in the text, they give you good examples. But I think just having these two things in your mind, am I really looking at behavior change or the process of how something's being done? Attribution, and quite honestly, if you're working in program design and evaluation, the stakeholders that you're working with, the funders you're going to have are almost always looking at this. If you are working in an area, and when I say this, I mean impact program evaluation. If you are working for an institution that's really quite institutionalized, they want to do some things better within that organization, and they're doing an evaluation within that organization, then you might work with some performance measurements. But quite often when you're looking at external type funds, you're really almost always looking at an impact program evaluation. Attribution of outcomes, they are to be determined. Are we meeting outcomes as we desire? We have a theory. We're going to test this theory with a hypothesis, and we're going to do some measurements to see if, in fact, we can attribute those outcomes to our intervention. In other words, can we really point at cause and effect? And on the performance measurement, you're looking at, it's assumed that if you make these particular changes in process, that you have met your particular outcomes, because they are kind of, again, process driven. All right, better examples, but I just want to draw your attention to the differences and when you're probably going to use each one of those. On impact evaluation, we'll talk a little bit more specifically about this. It's an attempt to demonstrate that an income is accountable or attributable to the program and not something else. In other words, you're trying to control oftentimes for a bunch of other variables or factors and saying that this intervention, we can really hang our hat on this and say that This is a program that, because we put it in place, we have been the result of this effect. We are the cause then of the change. And so that's something that's pretty important, but you need to be careful in making sure that you can make those kinds of claims, and they give you some limitations that I'll discuss here in just a moment. Success then, and they talk about the difference between a successful or an unsuccessful theory. The success of a theory, the if-then that you've put into place, is accurate, then you can say, I can say that I'm having an impact, I'm changing the effect because of what I did. Unsuccessful, they talk about whether the theory failure or program failure. You may have a situation where you have theory failure. In other words, you had this theory that if you, I mentioned this in a previous lecture, you have this theory that if you educate people about how to eat better, how to track their calories, all these educational interventions, that if you teach children about this, they'll make better, more healthy choices related to the food that they eat, and thereby you also institute some sort of intervention where you're going to educate them about the importance of exercise and so on and so forth to address obesity. And then at the end of the day, you find, oh this did not work. Theory failure. Well, your program may have been carried out exactly correctly. I mean, the program wasn't a failure. You carried it out just like it should have been. But your program may have failed because your theory was wrong. Maybe in reality is not just educating people about this is going to change their behavior. What's going to change their behavior is what I mentioned before, that they're pointing towards is parental involvement, so parenting types of skills. And so you've learned something from the study that you've done, but it may not help you with the theory that you had about how you could solve that problem. I also mentioned to you, obviously, the one about smoking. We all know that smoking's bad, but people continue to smoke. What is the proper intervention that's going to take place there to change their behavior? And your chapter does a pretty good discussion on this point, and of course I talked about it previously, so I hope you understand that. Research designs. So, like I said, there are entire courses about research design, and I think all of you are engaged in them, and you're going to be talk about these in multiple courses. This is a very surface look, but I did like what they used here in terms of the table to give you a kind of a quick overview. What I didn't like so much is it was not as easy to read. I've seen this same kind of table in other books, but let me see if I can help guide you through the way you should read this table. So you're looking for evidence of cause and effect. You're looking for evidence that the program you put in place, that intervention that you had, made a difference. So here are 3 types of impact for program evaluation, and I'm going to talk about post-test in just a moment. Well, let's take a look here at single group, pre-test, and post-test. So if you have a single group, you have one observation or some sort of data that you collect, some sort of analysis. It may be an observation. It may be a paper and pencil test. It may be some sort of performance. You have an observation. Then you have an intervention X. And then after the intervention, you observe them again, usually with the same instrument. You're looking at the same, you're measuring the same skills or the same knowledge, having them do the same performance, those kinds of things. That's the single group, pre-test, post-test. Also, I want you to notice that the word post-test and pre-test are one word. Something I learned in my dissertation. I had it hyphenated throughout. I think we changed it in 300 places. So just something for you to note, that in APA, the post-test, and actually Word doesn't correct it, so you'll need to do it. In fact, it thinks it's a typo, but it is one word. Type 2 test that they have here, non-equivalent comparison group. That means that you have 2 groups, maybe it's 2 classrooms, and you have an observation 1 and you have an intervention, and then you have observation 2, and basically that's the same as the pre-test, post-test on one group. But you have a non-equivalent group. They're not the same participants, but they're equivalent in other ways. Let's say that they are the same age, they go to the same school, and in this course there's the same numbers of boys and girls. The teachers have the same teaching experience, they are the same gender, and so you've tried to make as best possible equivalent groups, but they're not quite equivalent. And so you'll make a comparison between, and this is a good, it's a valid design. There are obviously limitations because there's going to be factors that you cannot control for, but you'll acknowledge those as limitations. But you would then use that group somewhat as a comparison group where you just have the observation, no intervention, and then observe them again. And then you would look at the differences between what they have here is O2 and O4 to see if you can determine more cause and effect related to, if you're looking for that evidence, the intervention that you had. Type 3, randomized experimental design, the gold standard in research. And that is where you have a truly randomized sample that you pick from a target population, and you have an observation, intervention, observation, and because it's random, you have been random with both groups, you can feel better about the controlling for, because they're random, you don't really need to worry about controlling for all the external variables because these groups are essentially equivalent. And so then you'd have an observation, no intervention, and then look at a measurement, observation for, and then compare O2 and O4. So that table is read across, and they do a pretty good job of explaining it, although I thought that maybe for me at least with this second group it would be O1, O2 again, O1, O2, but you are making a comparison, then maybe that's the reason they have it between these last two after you have your intervention. A word about post-tests. Post-tests only. Now, post-tests only, we do those quite often. We conduct a program and then we pass around an evaluation. We give them a QR code. We have them respond to some survey. We have them take some sort of exam in some way. We may even have them do some sort of performance. Can we have cause and effect? Do we feel comfortable with saying we have evidence that our program was the effect and then change of behavior? There are definitely limitations. And there are quite a few websites and some papers that have been written about this. I'm going to pull up one real quick. This is the Research Methods Knowledge Base. This site has a lot of great information. I use it in my evaluation course, my Reading and Applying Research course. And it talks about the types of designs, much like your text, gives a little bit more detail. Here on the bottom, though, unlike your text, it talks about post-test only. Look, that it's one word. Post-test only non-experimental design. You're not doing any experimentation between the two because you don't have a comparison group. In educational research, we tend to call it a comparison group. In some literature, they call it a control group. There's a move to go away from that. Control suggests that we can control for all the other variables going on. And in a social science setting, that's just really not feasible. Maybe in a controlled chamber where I'm sprouting plants, I can call that a controlled experiment. But you might want to use this design if you want to study the effects of say, for example, they say here, a natural disaster like flood or a tornado, and you want to do so by interviewing survivors. You notice that this is a design, you don't have a comparison group, but you could maybe interview the town down the road that didn't have a tornado to see what the differences were, that the tornado, the damage was caused to that other group. And you don't have multiple waves of measurement, e.g. a tornado level and how the ravaged town were doing before the disaster, right? You didn't plan on that. Does it make sense to do a non-experimental study? Of course. You could gain lots of valuable information by well-conducted post-disaster interviews or any other kind of evaluation tool that you use to gather information, but you may have a hard time establishing which of those things you observed are due to the disaster rather than other factors and peculiarities of that town, such things as geography, the types of buildings, maybe they had a lot of, and I know we see this on the news, a lot of trailers that get wiped out, whatever it might be, that might have been different in a town that had different geography and a different type of structure for their buildings. Let me bring that back to more of an educational point. So post-test design does give us some information. We can't, obviously there are some limitations here. We can't say that our program was, the evidence for the cause and effect that went on for a big change. But if we give some sort of survey instrument at the end of a particular program, we're conducting an evaluation and we want to know, do you think that this program was worth your time? Would you recommend it to others? We at least get some indication that our intervention was worth their time. They felt like they learned something. They felt like they would invite others back. Maybe they feel like they're going to change their behavior. So I feel like you can get some impact. We call it soft impact, but I would not use that kind of data to say cause and effect. And that would be the limitation. All right, looking for evidence of cause and effect with confounding factors. And they give you these, and you should be familiar with these from other research courses. You should also, if you're not familiar with them, see them in the literature. But these are some major threats to internal validity. I know that I cover this in a couple of courses, so I'm hoping that you get it in a couple, 2 or 3 different courses. If this is your first time seeing this, then get ready, you're going to see it again. So here are some threats to internal validity, and this means these are threats or reasons why we can't make claims that our program is the evidence supporting this cause and effect relationship. So you may have a problem with history. Events outside of the program differentially affect the scores of experimental group or the comparison group. So say, for example, you had a program and you implemented this program, got a good one, financial literacy, and you implemented this with 4-H, but you didn't realize that they were also getting this in public school. You didn't realize that this was a required course. And so you're doing this program and you're doing it with the same kids, and you see these astronomical scores and you're like, wow, these are great. And then you also notice really good increases in the comparison group where you weren't giving them program. Well, you've got history problems there, and you didn't realize that there were these outside events outside of your control taking place. Maturation, simply the passage of time differentially affects the scores of the experimental group or the comparison group. In other words, yeah, we measured them at the beginning of 5th grade, and they weren't able to do this particular performance or understand these particular concepts. But it didn't really matter. At the end of 5th grade, because of our intervention, they are now able to do these things. Well, the truth is if you didn't use a good comparison group, they may have gotten those skills without your intervention because they just grew up or they obtained that skill just over that period of time. They matured into that. They achieved it anyway. We use this one a little bit with ag literacy in that, yeah, kids don't know in kindergarten where milk comes from, but by the end of 2nd grade, they really do know, and it really wasn't because of an intervention that we had. It was because of all these other things that happened in their life, maybe sitting at the dinner table with their family, that they finally understand that milk comes from a cow. So maturation, they get there eventually. Mortality, differences in the dropout rate differentially affecting the scores of the experimental group or the comparison group. So you have attrition in there, you have dropout rate, and so maybe the people who left your program were bored. They already knew this stuff. And so by saying that your program impacts their learning, and you had so many leave that you really don't have good data. The ones that were there for different reasons. So if you have a lot of dropout rate, that could be a limitation in you being able to make the claims about cause and effect. Selection bias. Members of the experimental group and the comparison group are not truly equal on all important factors. And so I think that one stands on its own. If there's a bias for the way you selected the groups they set up, that would be a limitation in your study. And certainly when you submit it for publication, somebody's going to poke a hole and say, well, wait a minute, you picked all the students who were in the higher socioeconomic status, or you picked all of the ones that were in the lower socioeconomic status, or you picked all of the kids that come with really high grades or whatever it might be. You have to be very careful about selection bias depending on the program. Diffusion or imitation of the program. Individuals in the comparison group somehow became aware of the program information intended only for the experimental group. So this is basically program leak. And so they start to understand, and this happens oftentimes when you're conducting them in schools, perhaps could happen in 4-H clubs where people run into each other and there's a leak of information, and so now it's contaminated. Your comparison group has been contaminated, so to speak, and you really can't make any comparisons. Testing. Pretest differentially affecting the learning group or the experimental group or the comparison group. This is a situation where you give it a test and you don't have enough time between the pre and the post test. And because they know what's going to be asked on the post test, they know because of the pre-test, they remember what it is, they remember the answer, they had that exposure, you have a testing effect. And so the way to have this problem or this threat kind of go away and is to make sure that your pre-test and post-test are spread out. You can also impact this by changing the test questions somewhat, but making sure that they are still criterion or valid referenced, and that means that you ask the same question to get at the same concepts in a different way. So that's an internal threat. The last one that they list here is instrumentation. Implementation of the pre-test differentially affected the experimental group or the comparison group. That means that you changed your instrumentation. Your instrumentation was not valid between or reliable between the pre and the post, and therefore you have a problem because you used a different instrument. And there might be reasons that you had to do that. Maybe the one that you were using was too, for the pre-test, became too expensive for the post-test, whatever it might be. You changed the instrument and now you've got problems with reliability. All right, so those are some of the confounding factors, and those are something to pay attention to and that you have to discuss in your results, and also actually being aware of them before you start your research makes it so you can set up your research design in a better way. And of course, you're always going to be limited by two things that we always talk about, time and money. And so yes, sometimes we have samples of convenience, and that sample of convenience might mean that we have now selection bias. We have to acknowledge that, but there may be reasons why we use that sample of convenience. Okay, finally, case example, in the back of the text, in the end of the chapter here, there's a case example, Winter Park Elementary new curriculum. And quite honestly, I've been reading these as we've gone along, and most of them have dealt with some social services that I didn't think that a lot of you may have had a lot of experience, or you may not have really cared about. So in this case example, I think that this one's valid. It's about Winter Park Voluntary Preschool Center, and they are going to implement a new curriculum. And it's just a little short blurb on what they're going to do there. Again, this is a pretty small chapter, impact program evaluation and hypothesis testing, but it's a pretty important chapter because it really gets at, before you start even your data collection, how you're going to collect that data and how you're going to set up your research design so that you can actually, if you want to, determine cause and effect and do that in a way that you hopefully limit some of those threats to internal validity.